All right, we're going to talk about um, section 1, starting chapter 3. We're going to do quadratic functions, which we've already spent quite a bit of time on in previous classes, like Algebra 2, and even Algebra 1. So hopefully this stuff is familiar. You're going to learn to analyze these graphs. You're going to write quadratic functions in standard form, and you're going to find the minimum and maximum. Okay? This is what the book uses for a definition of polynomial. I would recommend reading this and try to understand some of this notation. It's just calling a sub n the first coefficient, and then the next coefficient will be a sub n minus 1. And then the exponents you can see decrease as well. But reading a textbook is a good skill, obviously, especially for college, because you're going to have to do that a little bit more. But this is our polynomial of degree n. We're specifically going to talk today about when n is 2, in which case you have a quadratic function here. All right? So a cannot be 0, so we actually have this quadratic term. Otherwise, if a is 0, we just have a line. These are parabolas. Parabolas have a ton of application. Okay? You might never use parabolas again in your life, but they do have a ton of application in like, for example, cell phone towers, or collecting any sort of electromagnetic radiation, for that matter, in general. Parabolas have that feature where they collect, they have a focal point. So anything that comes in, like parallel light rays, or if it's a lens for a mirror or a telescope, or if it's just a satellite to collect radio waves, or whatever it is, they all have that same property. They all reflect, no matter what rays come in, they all reflect to the focal point, in which case it basically amplifies the signal. So that's a parabola. Parabolas have tons of application. Like, you throw something and gravity acts downward on it, and that ball, if there's no horizontal force, is going to be a perfect parabola. So in outer space, an object would follow a perfect parabola. If there's very little wind resistance, an object follows a perfect parabola. Yeah. They just have a lot of applications. A lot of real-world problems are solved using these. I know we don't spend a lot of time on application, but it's at least helpful to know and appreciate that people have come before you and have used these things for something useful. And so now you can talk on your cell phone. So let's talk then about some other things that you might remember, like axis of symmetry. So axis of symmetry is the line that cuts the parabola in half. So all the points from the right side would be reflected over the axis of symmetry to the left side. So that's called the axis of symmetry. The vertex, is either a minimum or a maximum, depending on whether it opens up or down. Okay, so let's take a look at some of these. You have to remember how to shift functions and how to do scale changes for functions. So here's a perfect example. We did this in the last chapter, so hopefully you remember that if you look at a parent function like x squared in this case, and you want to determine what's different about 1/3 x squared, I like to divide both sides by 1/3, and then say, okay, I'm dividing y by a number that's between 0 and 1. So that would be a vertical stretch or shrink. And if you're not sure which one it is, once again, you can make a table real quick. The table for the original function, x and y, would be, you plug in 1 and you get 1, plug in 2 and you get 4, plug in 3 and you get 9. The new function, you look at that, when you plug in 1, you get 1/3. When you plug in 2, you get 4/3. When you plug in 3, you get 9/3. So you can see that these points were originally here, and now they're like this for the parabola. So you can see that this is a vertical shrink. So it's not that hard if you don't remember to just quickly make a table. And it's shrink by 1/3, by a factor of 1/3. So this one's going to be 1/3 as tall. Each point is going to be 1/3 as tall. Okay? We can do the same thing for this one. Divide both sides by 2. I like to look at it as, okay, if you're dividing y by 2, a number bigger than 1, then it's a vertical stretch. If you're not sure, you can make a table. But the original parabola looks like this, and the new one's going to be steeper. Okay, g of x will be steeper than y. All right? Okay, standard form for a parabola, we're going to call this vertex form. Okay? So I'll call it standard form for vertex form. It's y equals a times quantity x minus h squared plus k, where h and k is the center, and a determines whether it opens up or down. You are going to have to know that. I'll put that in the formula sheet. If you're trying to sketch a graph in standard form that's not in vertex form, without going through all the work of putting it in vertex form, the other piece of information I want you to know is that the x-coordinate for the vertex is at negative b over 2a. So for this one, when you're trying to find the x-coordinate for the vertex, that is always at negative b over 2a. I want you to know that that's the x-coordinate for the vertex. That will be something I put in the formula sheet, but so for this one it'd be negative 8 over 2 times 2 if you plug in b and a, in which case this turns into negative 2. So the x-coordinate for the vertex is negative 2. The y-coordinate for the vertex then would be if you plug in negative 2, in which case you get 4 times 2 is 8, plus negative 16 plus 7, which is negative 1. Okay? So the vertex of this parabola is at negative 2, negative 1, which is right here. I know it opens up, so it looks something like this. Now the axis of symmetry is the line that goes through the x-coordinate for the vertex. So this line right here has the equation x equals negative 2, right here. X equals negative 2, y can be anything. So this is the axis of symmetry. Okay? And this is the vertex. These are things that you need to know how to find by hand as well as with the calculator. To find it with the calculator, I think you guys probably remember this. I'm going to go to a standard window real quick. Alright, so if you plug this into y equals, and you take a look at the graph, you can see the vertex is at negative 2, negative 1. Now, if I want to try to find that, I can do second calculate minimum, because it's a minimum. Scroll to the left of that minimum point, and hit enter. Scroll to the right of the minimum point, and hit enter. Hit enter for the third time, and it gives you that minimum vertex, which is at negative 2, negative 1. Okay? The axis of symmetry then is just the x equals that x coordinate, so that y can be anything. Okay? Okay. Like I said, there's tons of application for parabolas. We could spend the rest of the years doing application on parabolas, all the areas in which in science and in manufacturing and all these different places where parabolas apply. But let's just do a little bit and then we'll move on. Here is baseball is hit 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees with respect to the ground. The path of baseball is given by this function then. I can actually show you where this comes from as well. Those of you that have taken physics, this is the relationship between distance. The initial distance equals the final distance plus initial velocity times time plus 1/2 gravity times time squared. This is the relationship between distance and time for any free-falling object on any planet. The only thing that changes is obviously gravity, depending on whether you're on the Earth or on some other planet. But this is the equation that represents free fall. So it represents motion of any object. Okay, that's where this came from. They plugged in the initial velocity. Looks like they're in feet per second. So that's how you get this coefficient here. But this says where f of x is the height of the baseball and x is the horizontal distance from home plate. What's the maximum height reached by the baseball? So what this parabola looks like is something like this, obviously, because this represents the height, and this represents, they said x was the distance from home plate. Okay, and this is the height. What we want to find is the vertex. We want to find the maximum of that parabola. Okay, we can do that by hand. If we know the x-coordinate for the vertex is negative b over 2a. So to find that by hand, that would be negative 1 over 2 times a, which is negative 0.0032. All right, we can also do it with the calculator. So let's find out what this is by hand real quick. 156.25 is our x-coordinate. So it's saying when we're 156.25 feet from home, that's when we reach the maximum height. But it says what is the maximum height? So we need to actually plug that in and find the y value of this function, because the y value of this function gives us our maximum height. So let's plug it in here. So we're going to square it, multiply it by a, multiply by 1 and plus 3. I'm actually just going to do it in this calculator right here. Now you can see I graphed the parabola by plugging into y equals. And you can see it goes like this. I'm going to extend my window so I can see. I know my window needs to at least go to like 300 because my maximum was at like 150 something. And my my Y max, I don't know how high the baseball goes, but I'm assuming it goes like 100 feet in the air maybe, or 50 feet in the air. So I'm going to extend the graph like that so I can see the parabola. Now, if I want to know where the maximum is, because I already know the x-coordinate, one easy way to do it is do second calculate value at 156.25. Because that is the maximum, and that will give me the y-coordinate, which is 81.125. So I know the maximum height is 81.125 feet. So you can do it on the calculator. You could also do it on the calculator by graphing it and then doing second calculate maximum, 4. Scroll to the left of the maximum, hit enter. Scroll to the right of the maximum, hit enter. Hit enter for the third time, and it will give you that maximum, which is 156.25 and 81.125. Okay, so after you hit it, 156 feet, it's about 81 feet in the air. All right, hope this helps. We'll try some homework and make a homework help video.